Let's finish up this lesson by solving some more complicated trig equations that are not on the unit circle. So we're going to start right here with tangent of x divided by 2 equals negative 3. Now, first thing we're going to do is do arctan to both sides to get the x by itself. So I get x divided by 2 equals arctan of negative 3. Now we are still going to be in radian mode. I want you to get used to doing these problems in radians. So if you put arctan of negative 3 into your calculator, you should get, I'll write this down so it's organized, negative 1.25. So it's negative, so this is 0 radians. This will be negative pi halves, or negative 1.57 radians. So that means negative 1.25 should be about there. So there's our negative 1.25 radians. Now, because we know this is tangent, the other quadrant that will have a negative tangent value is directly across from it, quadrant 2. And we know the easiest way to write the tangent answers is, instead of plus 2 pi k for both of them, is just to add pi k to this one. So if the problem said find all our answers, this is where we would be at. That's all of our answers. Except we do still need to solve for x. So let's times everything by 2. Get rid of that 2. So negative 1.25 times 2 is negative 2.5 plus 2 pi k. So if it said all answers, there we go. We're good to go. However, this does say between 0 and 2 pi. So I'm going to start with my first one, negative 2.5, and then I'm going to add 2 pi to it. 2 pi is the same thing as 6.28. So I add 2 pi, and I get 3.785. I add 2 pi again, and I get 10.068. Now remember, I only want the answers between 0 and 2 pi. So I only want my answers between 0 and 6.28, which means I don't want that one, and I don't want that one. Those are outside my restriction. So that is the only answer I want to keep. So let's do one more. I'll have you try this one. So same thing, start by solving for x by taking arcsine of both sides. So you get 2x equals arcsine of 0.87, which you're going to put into your calculator, get in radians. Find the two triangles that will give you that same sine value. Write all your answers and then narrow it down to 0 to 2 pi. Try this one on your own and then come back and check your work. Let's check your work. So first, I was solving for x, so I got arcsine of 0.87, put that in my calculator, and I got 1.055, which would be about right there, because I know that pi halves is 1.57 radians, so 1.055 radians would be there-ish. Now, the other triangle that would have the same y value, and I want y value because we're dealing with sines here, would be right here. This triangle also has the same y value, and the angle here would also be 1.055. However, that's not the angle I want. I want the angle in standard position, so I want that angle. So I do pi, the whole thing, minus my 1.055 to give me this blue angle of 2.086. So those are the two angles for this, 1.055 and 2.086. So if I wanted to list all angles, I would list them both plus 2 pi k. And this is equal to 2x, because that's what I still have over here. So I divide everything by 2 to get this answer and this answer. So if the problem said list all, this would be my answer. However, I need to go between 0 and 2 pi, so I start with 0.527 and I add pi to it to get 3.669. I add pi to it to get 6.81. Remember that 2 pi is about 6.28 as a decimal, so that would make my 6.81 too big. Do the same thing with 1.043. Add pi to it, add pi to it. 7.326 is too big. So those are my 4 answers. So that is all for lesson 4.3 for solving these trig equations. We have one more lesson in chapter 4, 4.4, which is where we're going to solve even more complicated trig equations. I'll see you there.